Good morning and welcome to the webinar. My name is Jennifer Adelstein and I'm the Marketing Assistant for Industrial Controls. Today's webinar is SteamTrap Application and Maintenance presented by Jeff Nelson of Industrial Controls. The presentation will take about 40 minutes, and after the presentation we will take some time to answer your questions. During the presentation, feel free to enter your questions into the chat interface on the right-hand side of your screen, and they will be addressed at the end. We will also open it up to voice questions where you can raise your hand and you will be unmuted so you can communicate directly with the speaker. Okay, at this time I'll pass it over to Jeff to get us started.
Thank you, Jennifer. As Jennifer said, my name is Jeff Nelson. I just want to thank you for attending our webinar today. I want to go over our agenda right now, and this will be what we'll be discussing for the next 40 minutes and hitting on each one of these subject matters. We're going to discuss what is steam. We want to get a good understanding of that. What is a steam trap? Where are they used? What are the various types of traps that are used? What causes trap failures? And the ultimate goal of this whole seminar or webinar is to discuss the costs and savings associated with your steam system. What is steam? This is something we need to understand. Steam is a colorless vapor created when water is heated to boiling point. In the industrial world and the commercial world, there are two types of steam. There's saturated steam. Many people think that means a wet steam, but it is not. Saturated steam is steam at a temperature of the boiling point which corresponds to its pressure. Saturated steam occurs when steam and water are in equilibrium. Superheated steam you'll find more in the power industry. Superheated steam is steam heated to a temperature higher than the boiling point corresponding to its pressure. It cannot exist in contact with water, nor contain water, and resembles a perfect gas. This is a nice little page here to show you a saturated steam condition where we're discussing gauge pressures. What you need to notice is as gauge pressure increases, heat or temperature increases. As gauge pressure decreases, you'll see our latent heat or our BTU transfer increases. What is a steam trap? Everybody hears the term. A steam trap is essentially an automatic condensate valve that opens the flow of condensate, air, and non-condensable gases and prevents the flow of steam. In all steam systems, we want to remove the water or condensate to prevent the loss of the BTU power of the steam we have. Here's a good example of where our steam traps used. Steam traps used are used in main steam headers, plant steam distribution lines, in your process lines for heat tracing. They're used at unit heaters for HVAC, at tanks for heating coils or jackets for your process, for process heat exchangers, and for sterilizers for pharmaceuticals. This is a relatively simple slide, but what we're showing here is the basics of where a steam trap would be applied and how you would use it. You obviously have your boiler off on the left-hand side that will be distributing steam at a higher pressure. The reason you distribute the steam at a higher pressure is it's a very small specific volume, thus you can use smaller pipelines. The steam would be at the high pressure taken throughout the plant. You'll notice that we have a steam trap at the end of main, generally at the low points in the main header. The steam then would be distributed to the different process areas. A good example would be on a low pressure system, usually an air heater that would provide a process trap, a process heat exchanger, tracers, jacketed kettles would then be returned back to your flash tank for reuse to make steam again. What are the types of traps? There are several different styles. One style is a thermostatic steam trap. They operate in response to a surrounding steam temperature. In the thermostatic family, there are three different kinds. There's a liquid expansion trap, a bimetallic style, and a balanced pressure thermostatic. In the mechanical steam trap family, mechanical steam traps rely on the difference in density between steam and condensate in order to operate. They can continuously pass large volumes of condensate and are suitable for a wide range of process applications. Basically, there are two common types you'll find. One is a ball float, and the other is an inverted bucket. Another family of traps is a thermodynamic steam trap. These have a unique operating principle, which relies on the thermodynamics or the dynamics of water and flash steam. They're simple, robust, very reliable, and can operate up to a very high temperature and high pressure. There are two common types. There's a traditional thermodynamic or disc trap and the impulse style trap. This slide here is indicating that this is our catalog that you can find both online and you can find, we can actually supply to you themselves. We can have it mailed out to you. If you look under our industrial valves section, you can find our offerings for steam traps. You would then follow down to basically page 30. We have two different types of steam trap offerings that we document in our catalog. We have Yarway and Watts McDaniel. What we're showing here is 3 pages that show differing styles of traps that are offered out on the market. To your left, you'll see basically a thermodynamic style steam trap. In the center, you'll see a Yarway power trap, basically for the high pressure, high temperature industry, the power industry. And to your right, you're looking at a repairable drip and tracer steam trap. These are all offered in our catalog on basically page 1105. And this would be an example of the type of information we would provide you with. Trap selection. This is imperative that the proper trap be applied to the proper situation. If you'll notice to your left, there are several types of steam traps, 5 different styles. In the center, we discuss operation, and we discuss typical failure modes. They don't always fail in this manner, but it's a typical or a normal failure mode. For a good example, you would be looking at a floating thermostatic trap. And when we talk about load, we're talking about the amount of condensate that the trap is sized to remove from your steam system. Basically, a floating thermostatic would have no action on low load. On light load, it would have usually continuous and may cycle some. On a normal load, it'll be usually continuous and may cycle. On heavy loads, it'd be continuous. And a normal failure mode for a trap like that may be in a closed position because the valve is at the bottom. Notice there's inverted buckets, bimetallic, and impulse. All of these traps have specific operating conditions and fit specifically in your system. This is, again, another page out of our catalog, and we're showing you a process thermodynamic steam trap produced by Yarway. In here we show you how to size and select. What you're seeing as we popped up on the right here is that every trap has a capacity that needs to be matched to its application. This is very important. As an example, if you were to look at where the arrow is pointing to on the left-hand side, a steam trap flow rate in pounds per hour, we're looking at 2,000 pounds per hour. As you move across the trap model here, you're looking at, let's say, an inlet steam pressure of 200 psi. If you follow the intersecting line between the 200 psi and the 2,000 pounds per hour, the selection would be a half-inch 4DD model steam trap produced by Yarway. This is on every one of our pages in our catalog, and we also can assist you with the sizing and selection ourselves if you were to contact Industrial Controls. This is a very good picture. This is a typical steam system that's been neglected. If you were to look in the upper left-hand corner, we're just depicting a steam trap system, a trap station that is having leak-by, corrosion, and many other problems, obviously. On the right-hand side, we're showing a disconnected steam trap that's obviously in a fail-open position. And if you were to look very closely, it's obviously been tested. There's a tag hanging off of the valve. So just testing the valve or testing the trap is not the only thing you should do. You need to replace and repair that to reap the benefits. What kind of problems we have with steam traps? In a system, 15 to 30% potential failed traps in systems that have not been maintained for 3 to 5 years. That means a 5% per year average failure rate. The live steam escaping to the condensate system or drain line, thousands of dollars wasted in energy due to the failed traps, and a major part of it is misapplied or poorly sized trap resulting in wasted energy or consistent trap failures.